And most of them concern web traffic. So we first compute the PCC, and what we can see, and we are a little bit surprised, regarding this 7 because this 7 action, the PCC is really very high. It's really very high, and the in general is high, but it's less than this result. In general is around 90%. I mean, if you consider the web traffic, the 200 attacks are more or less close to 90%. But regarding these 7 attacks, we're expected to get some low because they are very rare attacks, quite rare attacks, not very rare, quite rare attacks, etc. So and they are not. And there are 2 attacks which are not well detected by CART, which concerns the attack ED 1997 and the 4th attacks. We don't have a reason why, but it's not well detected. This is the point. And so this is global PCC. And if you look at the detection rate, we can see again that both of them are quite very good, except again for attack number 2, where the detection rate is quite low. And one thing that we have observed, even if globally, indeed, I'm not just speaking about this 7, but as a whole, even if globally there are similar performance with slight preferences to naive Bayes, but really not big differences. There are some complementarities. I mean, when we have tried to see connections by connection, which is not always easy to get it, we find a lot of complementarities. I mean, there are different conflict situations, if you like. And the question is how to use these complementarities. Of course, in the literature, there are different ways to use complementarities, but we have used a very basic one, very simple one, just to check whether there is improvement on the wall, and not just on this 7. As I said, on the wall it's around 90%. So we have really very basic way to combine. There are different ways to combine. So we are aware about it. The first one, if there is no conflicts between CART and naive Bayes, namely if you take some connections, or not connections, some windows, and either both of them detect severe attack, then the final decision is the presence of severe attack, or neither of them detects a severe attack, then the final decision, it's normal, not really normal traffic. There is no severe attack. This is the right word. So it's very easy, the case 1. And the case 2 is there is a conflict. So this is what we have used. As I said, very simple things. We have used 2 additional thresholds. The first one, theta 1, means there is a strong probability in favor of severe attack. It's not, when it exceeds 50%, we suspect that there is a severe attack. Here we took, I think, 80%. It's a really naive Bayes strongly believe there is a severe attack. It's not just. And similarly, when you theta 2, it reflects strong probability in favor of absence severe attack. Really, it means that the probability of not severe attack is very high. I mean, again, 80%. So if naive Bayes detects severe attack while CART doesn't, then if the probability of detection by naive Bayes of severe attack exceeds theta 1, then final decision will be severe attack. Namely, we ask whether the naive Bayes strongly believe there is a severe attack or not. So it's a very basic way. And now when CART detects severe attack while naive Bayes not, then again we ask naive Bayes to what probability you think that there is no severe attack. So if the probability is very high, then final decision will be normal traffic. Otherwise, it's an attack. And when you use this, we got serious improvement, because comparing to globally, we start from 90%. On the 7 there is no big because it's already 97, and this is a very simple way to combine these two tools. It gives a better result. So I will conclude. It's a really new correlation approach that has several advantages. For me, the first advantage is there is no need of a large amount of expert knowledge. Comparing of the main approach to detecting coordinated attack or complex attacks, precondition, postcondition is not realistic at all for me. And here there is we need some knowledge, of course. We need to specify for the training when objective and intrusion is achieved. Efficient and simple attack prediction, because here we use naive Bayes. If you use TAN, it's still efficient. If you use the more general structures, as you know, the decision problem, whether probability is equal to some alpha I, is an NP complete problem in general. So this is one of the reasons why you use naive Bayes. There are some complementarities between naive Bayes and CART, clearly. And there are a lot of things to do. There is, I will just mention 3. The first one is there are many uncertainty, because when intrusion detection say there is an alert, we don't know if it's really there is an attack or not. It's just suspect. Here we take it as. And obviously, this has a consequence. If you have a good intrusion detection, you will get a good performance here, definitely. And however, if you have a bad, I'm sure that because Snort has a huge number of signatures, if we replace Snort but another one, which is very weak, I'm not sure that we will get a good result. And the question is how to take into account this uncertainty. It's not obvious. It's not just because especially sometimes there are intrusion detection we don't know at all about reliability of this intrusion detection. So a new product or something like this. So this is one point. The second point, and I think this is a very difficult one, in the training we provide windows, these windows, and identification of the attack. However, when it tests, since we do it online, each time that action is reported, we report the actions. It might happen that in the same windows, there are several attacks, not just one. And for me, it's not easy at all. The way that we use one naive Bayes per several attack, it's in this spirit. It helps to deal with this problem. However, with CART, I don't know how it works, because training doesn't correspond to test. I mean, if you want really to use it in practice, because training, you have time to construct your windows, and each window is labeled just with one severe attack. While in the test, each action are reported as they arrive. And the third point, I will not go details, but what I think it's very promised, because logical based approach to alert correlation, because administrators at the end have some preferences to filter alerts, and it's good to have some automatic tool, not to learn beliefs or knowledge, but to learn preferences. And preferences is not equal to beliefs.